All right, in this lesson, students are going to use the converse of the parallel lines theorems to show that lines are parallel. So in this case, you don't know that the lines are parallel at first, and you're looking at the angles to show that they're parallel. Okay, and just to review, the corresponding angles postulate was the postulate we started with the other day, and then we proved the other ones. But just to remind you what it was, if parallel lines are cut by a transversal, then corresponding angles are congruent. I'm going to talk about congruence. Sometimes they interchange congruence with equality. What I'm going to write next is the converse of that. So that's where it's kind of like the opposite, and that's also true. So here's the converse, and this is the only time we're going to write it out kind of lengthy like this, and then we can abbreviate from here on out. But if two lines are cut by a transversal such that corresponding angles are congruent, then the lines are parallel. This is what we use to prove that lines are parallel. Eventually, you'll be doing that when we do proofs. We're going to use it today to just find unknown angles. But that's what you would use. You would show that the corresponding angles are congruent, therefore the lines must be parallel. So the converse is also going to be true for our theorem with alternate interior angles and same side interior angles. And when I talk about alternate interior, I also want to say alternate exterior angles. I haven't proven that, but that's another case where it's going to be true. Okay, so here's a typical example. What is the value of x to make the lines parallel? So we're not assuming they're parallel, but the work is kind of done the same way. If these two lines are going to be parallel, then these two are same side interior angles, and they would have to add to 180. So in theory, we're using those theorems to write our equation, even though we don't write that down. But they have to add to 180, so I'm going to add them up and set them equal to 180. I can distribute, and I get 3x minus 30 plus x plus 10 is equal to 180. So that's going to be 4x, and I combine the minus 30 and the plus 10, that's minus 20, is 180. 4x is 200. And it looks like x is going to be 50. So I go back and I'm looking, what is the value of x? So that's all they want to know. They don't even want to know what the two angles are. Well, for this to be true, for those two lines to be parallel, x would have to be 50. So this is 60 and this is 120, and they add to 180. So here we have a question that's just a diagram that's marked up. So there's no numbers to work, and we want to know which lines must be parallel based on this diagram. Well, I have two possibilities. M and N could be parallel, A and B could be parallel. So we have to look at these markings in here. In order for them to be parallel, I have no way to show if angles are supplementary or not. So we're looking for congruent angles and to see if they are any kind of our special angles. The only two that are congruent are this one here and this one over here. So if I look at this top picture and I ignore the bottom, if I want to sketch that out separately, what I have is M is the transversal, and I have these two guys. Okay, this is A, this is B, this is M. He's congruent to him. So if you look at that, these are alternate exterior angles. So therefore, A and B have to be parallel. I don't know anything about M and N cannot be. But A is parallel to B in this case because alternate exterior angles are congruent. Okay, for the next example, all I want to do is solve for x. So, and in this picture they have to be marked. Here we're given that they're parallel. So when you have those extra arrows in there, that means the two lines are parallel. Here's our transversal. In this case, this is an alternate exterior angle. So just like alternate interior angles, alternate exterior angles are going to be equal to each other. So you would set them equal to each other. You'd have 3 times x plus 7 is equal to 2x plus 61. Distribute the 3. That's equal to 2x plus 61. X is equal to 40, and again, that's all I'm looking for. So in this case, x is going to be 40. Okay, and we're going to finish with one more proof here. Here we have overlapping kind of L-shaped lines, and we're given that A and C are parallel and B and D are parallel. So given that, I want to prove that these three angles are going to be congruent to each other. So we always start off by writing our given. So A is parallel to C, B is parallel to D, that's given. Okay, so we can use our corresponding angles theorem, because if you look here, between A and C, line B is the transversal. Even though you don't see the rest of the line here, you could extend that. A line can be extended and where you could see it better. But K and L are in the same relative location, so they are corresponding. Same thing with M and L, because the transversal is C, so that creates these two corresponding angles. So here's what I can write with one reason. This is a very short proof, actually. You can say that angle K is congruent to angle L, and angle L is congruent to angle M. And that's because corresponding angles are congruent. So here's how you corresponding angles are congruent. And then by substitution, we have K is congruent to L. Now I can say that angle K is congruent to L, which is congruent to M. Oops. And I would just call that substitution. Okay, so that's another example of how we can prove different theorems in geometry.